Hey everyone, Justin Smith here from Laurier Economics. I'm just here to give you guys a quick tutorial on how to get started with the Students Mastering Intriguing Testable Hypotheses competition, the Smith competition for 2024-25. So this video is geared towards getting you started in R. There's a couple other videos that'll help you get started if you want to use Stata instead or Excel instead. So first and foremost, the thing you want to do is go to the website. Okay, so justinsmithecon.github.io/econcomp. And this is going to give you all the details about what's going on in the competition, what you're supposed to be doing, how it's evaluated, the timelines, the data, and all the rules. Okay, so presumably if you're watching this video, you've already signed up your team. So that would be the first link here. Second link is to download the data. Now, this year's competition is using the Canadian Labour Force Survey. This is the survey that that Statistics Canada uses to collect information on the labour market in Canada every month. So I've downloaded and stored for you 1 month's worth of that data as the training data set and a different month for the evaluation data set. Okay, so what's going to happen in this competition is you're going to be creating a model, and then you're going to evaluate that model based on the root mean squared error. So basically the average error in your prediction. Okay, and the team with the lowest error is going to win. The training data is the data that contains information on your wages, which is the thing you're going to be predicting, and all the other variables that you're going to use to make the prediction. You're going to, as the data set name suggests, you're going to be training your model on this data. So you're going to use that information to predict wages, and you can compare your wages against the real wages that are already in there. Once you're satisfied with your model, you're going to evaluate your model on the evaluation data set. Now, the key difference between the training and the evaluation data set is that A, they're from different months, so you're going to be predicting in a different month of the labor force survey. And B, the evaluation data does not contain any real information on your wages. Okay, only the variables that are used to make the prediction. The real wages are hidden, and it's going to be used to calculate the true root mean squared error in the background when you submit your predictions online. Okay, so the first thing you want to do here is just go ahead and download all of the data sets. For the sake of keeping things nice and tidy, I'm going to suggest that you create a folder on your desktop, call it whatever you want. I'll call it Econ Comp, and that's where you're going to keep all the files related to this competition. Okay, so go ahead and download all 4. Actually, in this case, since we're using R, we don't really need the Stata data sets. So we'll just download the 2 CSV files. So we're going to right-click and save link as. It's going to come up here to ask you to where you want to save it. You want to make sure you have the CSV extension on there, and then save. And then go ahead and save the evaluation data in the same way. Okay, evaldata.csv. Okay. You'll also want to keep handy the labor force survey. So I've linked here the website that describes each of the variables that's in the data set. We're going to pull that up right now just because. I'll just walk you through it quickly. This has the names of all the variables here, which is the same names you'll see when you open up the CSV file. Has a label for you here to tell you what that variable is all about. And then over here, you can view the categories. So for instance, if I wanted to know something about the different values of sex of respondent down here, I could click on here to view categories, and it tells me that the value 1 is for men and the value 2 is for women. We'll come back to this after. All right. So since we're going to be working in R, first thing you want to do here is open up RStudio. I can assume here that you know the basics of how to operate R. So I'm not going to go through, the relationship between RStudio and R. I'm going to assume you know how to do this. And it comes up with this blank environment here. As I always suggest in my stats classes, you want to make sure you store any code that you make into an input file. In the case of ours, this is called a script, so that you can rerun it later if you need to, and you're not going to lose your work. You don't have to recreate the commands every single time you open the file. Okay, so I've got this file here. Go ahead and save that. Save that as save that as intro to R. Okay. So people that have worked with R know that the first thing you want to do is load up some libraries that are going to be useful for you. In this case, we're going to operate in the tidyverse, and we're also going to need the metrics library, which you'll see later. Okay. Second thing is you want to set your working directory. So right now I've got the directory in an unrelated folder. All of the files I have are stored in this econ comp folder, which is visible down here. So I'm going to click into that. You see the evaluation data, the training data, and the intro to R. What I want to do here is make this the working directory. So the easiest way to do this is click on the cog and then go to set as working directory. Okay, and this is going to bring us to the econ comp folder as the working directory. I'm just going to copy and paste that into here. Now that we're all set, we're operating out of the econ comp folder. What I want to do is open up a data set. And again, there's different ways to do this. The easiest way for those getting started with R is to go up here to the drop-down menu in the top right-hand side here that says Import Dataset. We're going to be importing from text, and you want to use readr. Okay. And then we're going to try and find that file. So if you go to Browse and navigate yourself to your folder where you're storing all the files, you want to open up the training data. Okay, so open. Okay, it's going to bring up a preview of the data. Really, actually, all I want to see here is the code preview. That's going to allow me to open this data. I'm just going to copy the second line right here. Okay, so I'm going to go ahead and actually cancel out of this, put that here, and then run that command. Oh, and looks like I also need to add the readr library. Okay, so now I've run all those commands, and you see the training data has now appeared here. So there's 42,000, just over 42,000 observations on 29 variables. If I click on train data, it's going to bring up a spreadsheet of all the variables here. Okay, so we've got the record number, province, sex, marital status, education, and then the key variable over here is HRLY earn, hourly earn. This is the thing that we're trying to predict. So while I'm here, might as well go ahead and open the evaluation data and save that. So I'm going to copy and paste, and I want to just call this eval data. So the process is the same, except it's just called eval data, and I'll run this here. Okay, so I've got the training and the evaluation data all loaded up. Now we're ready to model. Okay, so remember, we're modeling on the training data. And there's a whole bunch of different ways you can make your model. I'm just going to give you a quick rundown of doing this with a regression. Again, you can do this any way you want. Regression is something that we're familiar with as economists, so I'm just going to do a simple linear regression. Okay, so I'm going to just call this, let's say, model. Okay, and the command for doing linear regression in R is lm. And the dependent variable, as I mentioned before, the thing we're trying to predict is hourly earn. Now, what do we want as our independent variables in the model? Okay, what do we want to use to predict the hourly earnings? this is something that I'm going to leave up to you. I'm just going to show you a really simple way with just a couple of variables here. Looking back at the data, maybe you think that the person's wage is related to how long they've been on the job, and that's tenure. Okay, you're going to notice some values down here. It's going to pull up the labor force survey one more time, and just to double check what the units are for tenure. So I want to see all variables. Where are we here? Oh, so items per page, you want to put that down to say 60. Navigate down here to tenure, and you see that tenure means job tenure with current employer in months. So those numbers there that you see in the data are the number of months that the person has been with that job. Okay, so I'm going to add tenure as one of my independent variables. Now, the other thing you might notice about this data is that there's a lot of data with small numbers here, and these are actually, so for example, sex, marital status, education, these are all categorical variables. And the numbers here represent different categories. We already looked at sex here where which was it? I believe 1 was men, 2 was women. So just navigating back to that. Yeah, 1 was men, 2 was women. Okay. And then education looks like 6 categories, and there's other categorical variables as well. Now, the one thing that's really key to remember is that variables like sex and marital status are unordered categorical variables. These numbers here don't actually mean anything at all, except there's placeholders for what the category is. And a big no-no in statistics, in regression, is to try to insert an unordered categorical variable as though it were numeric, right? So if I tried to put the variable sex in there, what's going to happen is it's going to treat this as a numeric variable. Okay, it's going to treat those numbers as if they mean something when they actually don't. And what you're going to get out of that is a whole lot of nonsense. So what you actually want to do here is tell R to treat this as a factor variable. Okay, and a factor variable in R is categorical. And what's going to happen in the background is that R is just going to create what's called a dummy variable, which is a special type of variable that takes a 1 or a 0, depending on if you're in a category or not. And it's going to put that into your model instead. Okay, and the easiest way to do this, so one way to do this is to declare that variable is a factor in the data set. Another way to do this is just to, inside the model, put as factor, and then give it the name of the variable. So what R is going to do here is treat this as a factor variable when it enters it into the regression. Okay, so this is a simple model based on how long you've been there and the sex of the respondent. Okay, so what I'm going to do here is run that. Oops, forgot one thing. You got to tell it what the data is. Okay, so data equals train data. Train data. So if I go ahead and run this, you'll see that it executed something and it shows me nothing. Okay, if I want to look at the actual coefficients from my model, I just type in model down here, and it's going to show me, first of all, the formula that it ran, and second of all, the coefficients that it estimated. So we have an intercept here of 34, so $34. Your wage is going to increase by about 4 cents for every month of extra tenure. And it's going to fall by $4.65 for factor level 2 versus factor level 1. Remember, factor level 2 was women. Okay, so this is sort of the gender gap in wages. Okay. Now, when you're working with the model and training it, you always want to check to see if what you're doing with your model is improving the root mean squared error. Okay, so what I might want to do here, first of all, is check out the mean squared error. Okay, so one way to do that is to use the RMSE command. Actually, you know what? I'm just going to do it right in here, right in the command window. RMSE is part of the metrics package, and it allows you to calculate the root mean squared error. We want to calculate the root mean squared error between hourly earnings and its prediction. So we know that the root mean squared, or sorry, the actual wages here are called hourly earn. Okay, so that's located in the training data set. So we want to use the training data set and use variable hourly earnings. And now we also want to use the model to predict hourly earnings and then put that as the second variable in this calculation. So so what we want to do here is predict model. Okay, and this is going to predict the dependent variable in the model and substitute it in there for the second variable in this calculation. So we see the root mean squared error here is 17.82. So this is using the training data to calculate the root mean squared error. So on average, we're off by $17 in terms of our prediction, which is not great. You could probably do better than that. As you tweak your model and you find that the root mean squared error is getting lower, maybe you want to stick with that model and then keep going. Okay, so keep playing around with it. Decide on the model that works best for you. Pick the one with the lowest root mean squared error. So once you're satisfied with your model, the next step is to actually create the prediction from the evaluation data set. Okay, now the best way to do this is to use, again, the predict option, the predict function. So what we want to do, maybe save this in terms of a different object. Let's call this final prediction, final predict. And what we want here is to create a data frame. I'm actually going to create a tibble, which is basically the same thing as a data frame. And I want to save the things that we need to be able to submit this to the website as our final prediction. So looking back at the website here one more time, you'll notice that under the submissions heading, I ask you to submit the record number and a variable called P hourly earn. Okay, and this is critical because if you don't have those two variables in your prediction, when you submit your prediction, it's not going to calculate the root mean squared error automatically. So make sure you have those two variables in there. All right, so what I want here is a tibble that contains the record number. So I'm going to call this rec num, and that's going to be equal to the record number from the evaluation data set. I also want it to contain the predicted hourly earnings. So P hourly earn is going to be equal to predict model. So you want to use your model to make the prediction. And you want to add an extra argument in here to tell it that you're making the prediction from the evaluation data set and not the training data set. So comma eval data. Okay, and so if I run this, we get this data frame here, tibble called final predict, and that's going to contain the record number and the predicted earnings. Okay, so this is all you need to be able to submit. Now, the submission has to be in CSV format. So the last command here is you want to save as a CSV. Okay, so the command, one of the commands for that is write CSV. So the first argument you have to give it is what you want to export. In this case, it's the final prediction. And then the second one is the name of the file. So this should be the name of your team in all lowercase letters, no spaces. So if my team were called the Deadweight Losses, this is how I would do it. So deadweightlosses.csv. Okay, and you can go ahead and run that. Okay, just going to go ahead and save this. Now, if I pull up my folder again, you'll see now that I have my intro to R script, and I've got my deadweight losses CSV file. So you just want to open that one time just to make sure that everything was loaded up correctly in there. And you'll see here we have the record number, the hourly earnings, so everything seems to have been saved okay. All right, so close that up, you don't need to save it. All right, so the last step is to go down here to the link that tells you where to submit your predictions. You'll see there's a link to the submission form. Click on that. All right, there's some instructions here on how to do this. Add a file, and you want to add that CSV file that you just created. All right, so that's deadweightlosses.csv. Open that up, and then hit submit. And you'll see the your response has been recorded page. And then that's it. Now, you just need to wait until the end of the day, sort of around midnight, where in the background it'll process all the submissions and then update the leaderboard. All right, so if I scroll back here to the leaderboard, you can see that this is something I submitted earlier. Your submission will appear here at the end of the day. Okay. Key thing is to make sure you look here to see when it was last updated. If you don't see your submission there, maybe you checked too early. The other reason could be that you made a mistake in naming your file, or you included the wrong variables in there or something. Okay, so if you don't see your submission, even if you've submitted, just double check to make sure you've done everything correctly. And that's it. Okay. I just want to say one more time that what I've done here is just made a very simple model. You are going to use this as a way to springboard yourself into creating more complicated models, and then make those submissions. If anyone has any questions, please reach out to me. All my contact information is right here. Okay, jusmith@wlu.ca. Thank you.